you just said one of the coolest things, and I wish I had record going. Let's see if you can say it again. When I said you probably got a lot of hate in your DMs, what did you say back?
Oh, I just if I get a lot of hate, I just insult them back. If you're gonna insult me, I insult you back. And if you want to be nasty, I'll play that game too. It's just how I roll.
That's awesome. No, I love that. I love watching your Twitter feed, and I'm also glad it's you fighting the fight and not me.
It's a pain, but it's rewarding in the end because you realize that you have a lot of fans. For every hater out there, you got 20 fans. So it's been rewarding in a way. I never thought that in doing this when I started this that I could fill up an arena with fans. So it's pretty cool um, to have this opportunity and be able to get my word out there to as many people as possible. It's been really fun. I've been able to really through this make a lot of great connections to wonderful people that are in this fight, from people that are on the policy side to actual scientists who support kind of our position on this. So it's been a wonderful networking opportunity. It's opened up a lot of doors. It's closed some doors too, and as far as the mainstream route, but it's opened up a lot of doors. I'm working with CFAC this summer. I'm interning with them. Great group of people.
No, this has been awesome. So, kind of, a device I always use, kind of to start the podcast is, level set. And my mom is really smart, but she doesn't know who you are. So, give the short version of kind of who you are, who's your story, and how you got started throwing firebombs at on Twitter.
Well, so for those who don't know, my name is Chris Martz. I'm a senior meteorology student or senior meteorology major at Millersville University in Lancaster, Pennsylvania. You always have to say Lancaster because they get upset if you say Lancaster, because I'm from Virginia and I say Lancaster. They go up there, they're like, it's Lancaster. I'm like, okay, okay. So I graduate
Yeah,
next May,
yeah.
the May of spring 25, with my bachelor's of science degree in meteorology with a minor in emergency management. I wish I had done a minor in data science as well, but it's a little too late to start that because I want to graduate on time. Um, but I really got interested in this. I wanted to be an engineer for the longest time. And I had a teacher in high school that I kind of fell out of love with that because of just kind of what we did. Um, and So then I kind of got interested in weather, but what really sparked my interest was in December 2015. We had one of the warmest. I think it might be the warmest December on record in the contiguous United States. And I remember it was we were sitting in church on Christmas Eve for the Christmas Eve service, and it was 75 degrees outside. And we didn't have any AC because it was the winter. It was winter, and it was like really hot in the congregation room. And did the candlelight service, and we sang Silent Night, and I was just sweating like crazy. And I remember going out and just thinking about how it should not be 75 degrees on Christmas Eve. This is ridiculous where I'm from. It's not like it's Florida or Texas. It's Virginia. And I was kind of concerned that really got me concerned because I had this picture in my mind. And I don't know if it's just from the fact that your memory kind of, you don't remember things correctly, or if it was just that I got used to all the Christmas movies, but I had this idea that around Christmas time it was always cold and there was always snow on the ground, and it was always cold during the winter. And my teachers through elementary, middle school, high school, it all ingrained in me this idea that we are facing a climate catastrophe, that all these bad things are happening because of our burning of fossil fuels, oil, coal, natural gas, and that it's causing the planet to heat rapidly. And if we don't stop it through government intervention, it's going to lead to all these bad things. Glaciers are all going to melt, sea levels are going to rise 70 feet, and we're going to see all these extreme weather events. And I was never really, I've always been taught to think critically, but I never really put much like vested interest in this issue. I just kind of went along with it. I didn't really think much of it, but I was a little, after this December 2015, I was kind of started getting concerned that, okay, this is really warm. We shouldn't be having this during the winter. And it got me really concerned that, okay, maybe these people have a point that the world is heating too much and it's because of us and we need to do something about it. And then I was like, this is unprecedented. The media is telling us, these journalists, some of these scientists are saying that these extremes are unprecedented. We've never seen this before. And so I began to believe it a little bit. And then fast forward to January 2016 on my birthday, we had a big blizzard on the East Coast. I think it was New York City's largest snowfall. I think it was 27.3 inches for them. DC got 17.8 inches, which is one of their largest storms. Although they lost the measuring stick in the middle of the snowstorm, so they probably got more because the White House got 2 feet. But Reagan National got 17.8 inches. That's not believable. And we got 3 feet of snow at my house, and it was we had a big Arctic outbreak after that. And I was kind of like, okay, this is weird. We had this really warm, record warm December, and all of a sudden we're now having this big blizzard. Either the weather's getting more extreme. This is ridiculous. And then we had, 2017, we had Hurricane Matthew, or not Matthew, Hurricane Harvey and Hurricane Maria. And there was 3 major hurricanes that summer. Harvey was the worst, most devastating of them. It caused a lot of damage in the Houston area. And their media was telling us this is unprecedented. This has never happened before. And I believed it because scientists were saying it too. And then I came shortly after that, about 2018 or so, I came across I was just scrolling through YouTube and I came across by chance Tony Heller's channel. And he does all these these videos. He used to make much longer videos and that were much more in depth. And he would go over extreme weather events and temperature data of the United States. And he began showing me that he began showing these videos that hurricanes there had been far worse hurricanes, like the Labor Day hurricane in 1935, Okeechobee in 1928, the Indianola, Texas hurricane of 1886, Galveston 1900, Galveston 1915, Camille in 1969, Donna in 1960. Hazel.
Galveston would have been Houston if not
Yeah.
for that hurricane. So that
Yes, it
was a
was.
big deal,
They get
no
killed
doubt.
between 8 to 12,000 people, and it was one of the most intense hurricanes to make landfall in the United States. So I never was aware of these storms because nobody ever told me about it, and then Tony Heller did. And then because in back of my mind, I've always had this. Okay, I need to question what I'm told. So I went on Google and other publications or whatever, and I found that okay, what he's saying is legitimate because I always double check what I'm told. I try to double check. I didn't really do that necessarily with the climate. I was kind of skeptical at first, and then we had this really warm December. I was like, okay, this is weird. We had a couple of really hot summers. I was like, okay, this is maybe they have a point. But then Tony showed me a different kind of perspective about it, and then he started showing me that heat waves were far worse in the night before 1960, particularly than the 1950s, 1930s, and 1910s. We had really hot summers in 1954, 1953, 1952, 1939, 1936, 34, 30, 25, 1918, 1916, 1913, 1900. So, and 1901. So we had all these really, really hot summers, and they were far worse than anything we really seen in the last 20, 30, 40 years. The only comparable summers in that time period would be 2010, 11, 12, particularly 2011 and 1988. So those are the only, and 1988 is when a lot of this global warming hysteria really started with Dr. James Hansen's testimony to Congress. And that's when all this really gained footing because he had the IPCC founded in 1990. But then I came across Joe Bastardi's page on Twitter. I got a Twitter account, followed him and Tony Heller, and they began, the two of them know weather history. Like they could name you any heat wave statistic or hurricane or whatever, going back to whenever records began, say 1850, 1870. They know weather history more than anybody else I've ever seen, and it's impressive. And somebody on Twitter the other day told me, they said, well, you're just taking 2 random guys on the internet, their word for it, not all the thousands of scientists who study these historical weather patterns and learned about them in school. And I'm like, okay, I go to school. I'm a meteorology student. I'm an atmospheric science major. They teach us the physics of how the atmosphere and ocean work. They teach us how to forecast a little bit, but not much. It's more of a kind of just a physical science program. That's what they teach you to be a scientist. If you want to learn about weather history, you have to do that on your own. If you want to look at historical patterns, you have to do that on your own. And that's what Joe has done for decades. He worked for AccuWeather for 32, 33 years. And then Tony Heller is a geologist. He's been doing this for a long time. So he's been studying this stuff on his own. And if there's anybody who knows weather history, it's them. So they showed me a different perspective that I've never seen before from the news media, from mainstream scientists like Dr. Gavin Schmidt or Dr. Michael Mann, who both, Michael Mann has me blocked. He blocks everybody. So they showed me a perspective I hadn't seen, and it began to have the wheels turning in my head. Okay, that maybe this isn't a climate emergency. Maybe we have had these extremes in the past. And the more I've dug into it, I've become really well versed in a lot of this stuff. There's some areas that I'm not as great in, such as like the physics of radiative transfer and some of the like the aerosol and the way the radiation works. That stuff I'm trying to get more into. We had a radiative transfer course, but that's something that William Happer might be more expertise in. My expertise is more in the extreme weather kind of aspects of things, because that's what I study is meteorology. So that's where my strong suit is in this. But there's a lot of great voices out there, and I've really been able to network with wonderful people through this, and it's really, I learn something new every day. So being able to have my mind changed about this, and people always tell me, Chris, your judgment's clouded because you're getting your information from big oil frauds that are pushing climate denialism to destroy the planet or something like that. But the reality is that my judgment changed once I had a second look at this data. So what I tell people all the time is that maybe it's not my judgment that's clouded, but it's yours, because I once had your position.
Yeah, one of the things I've found interesting about watching your Twitter feed, as well as just me anecdotally being in the energy business, kind of watching this stuff from a side, and I'll kind of fire this out. When we look back, call it the last 10,000 years, it looks like we're coming out of a little bit of an ice age, whatever. I've read some stuff about that. How good is that actual data? Like, if we had put politics aside, we're in a closed room where no cameras would be on anyone, and you had scientists in there. Is there any sort of range of confidence we have on that data? Because I can't ever get a good assessment of that just reading about it.
Well, it's always interesting because proxy data, what you're referring to, you can estimate past temperature and precipitation patterns for a specific look. Say if you pull a ice core out of Antarctica or Greenland, that's not going to give you a global picture of what's happening. That's going to give you a picture of what happened maybe there. Um, and there's a lot of uncertainty with proxy data. I don't know what the confidence interval is or what the range, the percent error is, per se, because I haven't studied paleoclimate in the way that somebody like Stephen McIntyre has. But what I do know is that they're okay estimates. But there is a bit of uncertainty with them, and being able to, because you have to calibrate the width of, say, like a tree ring or a layer of sediment, because they get layered with time. And if there's like darker sediments, it's more organisms that lived in, say, the ocean. And so when they died and they sunk, there was more organisms in it warmer, when the oceans were warmer versus when the oceans were cooler. And the width of that, the depth of that layer of fossils or sediments or whatever, can tell you kind of what the temperature was at that time and how long it was that warm. And you have to be able to calibrate it to kind of a thermometer to be able to really do that well. But again, there's a lot of uncertainty. The best temperature proxies would be sediments, because again, if you have warmer oceans, then you have more organisms living in the water, more fish, more sea life. And so if it's warmer, that life's gonna proliferate. And when they die, they're gonna compress and sink into a layer of sediments. And when the ocean's cooler, then you get a layer of sediment is filled with all these fossils and stuff. So that's a good temperature indicator. Ice cores are the oxygen isotope, stuff like that's good because of the way ice expands and freezes and melts or whatever. But tree rings, on the other hand, are because that's what the hockey stick graph, Dr. Michael Mann's hockey stick graph, the infamous hockey stick chart, that's what that's based off of, is tree rings. And tree rings are not a good temperature proxy at all. And because the width of a tree ring and how much a tree grows is dependent on a lot of things, whether it's dry or wet. It can be hot and dry, it can be cold and dry, it can be warm and wet or warm and dry. It depends on the climate, and it depends on the weather patterns for a given period of time. There's also other stresses and stuff that act on trees. You got insect outbreaks that can hamper. If you have invasive species of insects, that's going to reduce tree growth, and you're not going to get as a wider width of tree rings for when it's warmer. And one other problem with the tree ring data, and Michael Mann and his team, when they did this, I think it was a 1998 study that this really started. What they did is they went around to different locations and they pulled, samples of tree cores out, and they looked at the tree ring widths and they calibrated it and created this temperature chart. But what's interesting about the hockey stick graph versus reconstructions from sediments and ice cores or whatever, pollen, whatever, they all show that kind of this wide range of temperature variations. They show over the last 2,000 years. They show the big medieval warm period, which is about as warm, if not maybe a little bit warmer than today. We don't really know. And then we had this massive drop into the little ice age. And then since then, we've kind of recovered. And we're, if you look at the proxy data, we're not quite as warm as the medieval warm period, at least in the northern hemisphere, which is where most of our land mass is. So that's where the largest temperature variations are going to be, because ocean doesn't heat up as much. Water has a very high specific heat, which means that it takes a lot more heat in joules to warm 1 gram of water by 1 degree Celsius or 1 Kelvin than it does, say, asphalt or soil or concrete or air even. So it's going to take oceans a lot more time to heat, and there's more land in the northern hemisphere. So what happens in the northern hemisphere is kind of going to dictate kind of the trends on a global scale. It's going to have a heavier weight on what happens globally. So at least in the northern hemisphere, if you look at the proxy reconstructions, we're not as warm as the medieval warm period. But although that reconstruction kind of ends around 2000, because we don't have enough, it hasn't been enough years since then to be able to add another data point to that. So it's difficult, because you have these 10 to 20, 50-year intervals for where one data point represents. It's an average of that time. It's not, we don't have proxy data for every individual year. So when people say it's the hottest year under 125,000 years, we don't know that, because we don't have instrumental temperature data on a daily basis to be able to know, okay, what was the average temperature for January 1st, January 2nd, all the way to December 31st, average that for the entire year 125,000 years ago. And proxy data is not refined enough temporally to be able to do that. And the longer you go back, the more spaced out proxy data is. So you might be able to go back to the mid-little ice age, and you might be able to get 10-year means for what the temperature was, say in the 1750s, 1760s, 1780s. But you go back 20, 30, 40,000 years, 400,000 years, 800,000 years, those data, that average is going to turn into 50 years to 100 years to 200 years. It's much less certainty the further back you go. But what's interesting about the hockey stick graph, on the contrary, is
the analogy for that, the oil and gas business, and very similar, is geology, right? Because you're trying to figure out downhole where the rock is, if you need any structure, any capture, and the geologists come in, and with so much confidence they draw these maps and they show you exactly where the oil is going to be, and they never tell you that, like, when you shoot seismic, you literally have a data point, call it every 50 or 75 feet. The stuff in between, they're extrapolating. Now, in a lot of situations, you wind up with enough in the way of data that you can make those extrapolations. But in some place where you don't have well penetrations, I mean, they're just freehand drawing this stuff. But
exactly.
they say it with such confidence.
Yep.
Oh, here's where it is. Early in my career, you go drill the well. It was a dry hole, and it was like, oh, well, don't know why. It's kind of like, so yeah, same thing.
That's a great analogy, and yeah, you're right. In interpolation, extrapolation is sometimes it's good, but a lot of times, sometimes it's not. You can make huge errors in doing that. You do it when we have to do isoplothing on weather maps, where you connect the dots and the contours on temperatures. If there's not enough temperature data, you're really guessing things. And if you look at a comparison to what an actual map looked like, because the professor gave us a map of those random temperatures, one with a lot of temperatures, a lot of like data points, and you just connected the dots for the isotherms, the lines at equal temperature. Then he gave us a map with very little of that data, and you kind of had to really guesstimate where that is. And then you look at the actual map, and it's like, oh my gosh, my drawing's awful. So when you make those guesses, sometimes it's good, sometimes it's not. And that goes with what you were talking about, and that goes with proxy data. But one thing I wanted to mention about the hockey stick graph of Michael Mann's infamous hockey stick curve is that unlike those other reconstructions which I mentioned, which was actually backed by, there was 3 studies which backed the kind of what I was talking about earlier with the big variations in temperature. I don't know the names of the studies off the top of my head, but I have posted about them on Twitter several times. One of them was in 2000. Moberg et al. 2005 was one of them, and the other one was, it was like some German name. I'm not even gonna. It starts with an L. It was from 2010. I'm not even gonna bother butchering that. But what's the hockey stick graph, on the contrary, which is done by tree ring analysis, kind of shows a stable kind of climate. It is just kind of static with a slow descent into a colder period, which was the Little Ice Age. And then it shows this big curve upward to the modern day. And what's interesting about that is that doesn't match any of the other reconstructions. It doesn't match any of the regional reconstructions that you can pull out of Greenland's ice cores or Antarctica or from any other place really in the world. Because a lot of individual reconstructions for, say, India, somewhere in India, or China, or the Western US, they all show this medieval warm period, and they all show a Little Ice Age, although the timing might differ a little bit by a few decades. They all show this kind of similar pattern on pretty much anywhere in the world. There's a whole site called Medieval Warm Period Global. But the hockey stick just shows that this climate was static and it wasn't really changing a whole lot. And then all of a sudden we get to the Industrial Revolution and we have this alarming curve upward. The problem with this data, not only that it doesn't match any of the other data really, but the other problem is that if you look at the tree ring data in the area where it's supposed to be warming, where we have instrumental temperature data, the tree rings actually show that the Earth has been cooling. And that's where the whole hide the decline, Mike's nature trick, that's what they talk about that. They practically eliminated that data from the proxy data, and they just spliced instrumental temperature data onto the end of that record to show that warming. And one thing in science that you should never, ever, ever do is do data splicing. That's where it might be the same data, but it's from 2 different methodologies. So and NOAA does this all the time, for example, with sea level data, is that they have the tide gauge data, which measures relative sea level, which was where the position of the sea level relative to the Earth's to the tide gauge. So relative sea level shows that it's kind of been going up at a constant rate since Abraham Lincoln was president, and at practically every tide gauge where there is an upwards trend. But then they show from the actual sea level measurements from the satellite data. They started that in 1993, and they add that onto the end of the record to show this upwards curvature, this acceleration in sea level. You shouldn't do that, because relative sea level and the actual sea level rise measured by satellite data is in 2 entirely different methodologies. And relative sea level trends can be dependent on vertical land motions called VLMs. And it's shown in several studies. There was 2 that I posted out on Twitter. I don't remember the names of them off the top of my head, but 2 studies analyzed the relative sea level trends across pretty much every tide gauge around the world that we have long-term records at. And what we see is that in the vertical land motions, which is geological, like post-glacial isostatic adjustment, glacial rebound, where the land is sinking. The relative sea level is going up. So along the East Coast, most of the perceived sea level rise that we have seen is on the East Coast of the United States, for example, and also in the Mediterranean and also in Australia. Most of that sea level rise that's perceived is actually just due to the natural geological land subsidence and the fact that we build 20, 30 floor resorts and condos and apartment complexes along the coast doesn't really help that, especially in areas like Miami Beach, where you have this sandbar that's basically a city built on a sandbar. So it's helping that sink further. So obviously that's going to be a problem. The ocean, the relative sea level rising is going to be a problem for these communities in a few hundred years. Not so much places like Myrtle Beach, but places like Miami, definitely a problem. Somewhere like New York City, not as much of a problem because the land's not sinking as much there. And yes, the sea level has risen a little bit, only by about 8 inches over the last 100 years. But over the last 20,000 years, sea levels have risen by 400 feet, during most of which during that period, it was rising at a much faster rate than it is today. But kind of got off topic there. But the hockey stick graph to the temperature, you should never data splice. It's unethical, and you can't do that when you put the two different data sets of different. You put the same data set but two different methodologies. You can't do that because it's just not. You can't compare. They're not comparable. If that makes any sense. And the hockey stick graph, it just
that makes
go ahead.
well, and keep running with that, and I'll layer on one other sort of big picture thought for you to touch on is, okay, we've been fairly civilized, fairly advanced since 1850. You know, we've been taking measurements of temperature and all. I read something, and this is wrong. I'm just spitballing a big picture kind of theory, and I'm probably messing up details, but it basically said if you look at all the recorded data we have on temperature over the last 150 years, I mean, basically, I think the environmentalist side of the argument is we're up a degree and a half, 2 degrees over that last 150, 175 years. It's because we've been burning hydrocarbons. CO2 levels have gone from whatever 300 parts per million to 425 today. That's what's causing it. I've heard, and the question I'm asking is opine on the quality of the data over the last 150 years. But I've heard something to the effect of if you actually just look at the raw data, the actual temperature written down on all these records, it's kind of hazy. It looks almost like temperature's been flat. It's when you get into the interpolated data of, hey, we used to take measurements at 10 in the morning. Now we take them at 3 in the afternoon. So to the old data, we add this, or we moved closer to an airport. There's more concrete there. We've changed the data. It's really the data we're manipulating that's showing this temperature rise. And I've always wondered, the question is, you know, is that because we've manipulated it that way, or are we totally missing the fact maybe it's even worse than we thought because our manipulations aren't correct? So take that disjointed mess of a question wherever you want.
That's actually a really good question. That's actually one of my favorite questions that people have asked me, because it's very interesting. Um, it's estimated, if you just take it at face value, so you take the HaCRUT data, HaCRUT 5, NASA GISS, or Berkeley Earth, or whatever data set you want of the instrumental record, based on land-based thermometers. It's estimated that we had about a 1.2 degrees Celsius warming since 1850, 1880, somewhere around there. Depends on when the data set starts. Berkeley Earth goes back to 1850, although there was like no thermometers at that time, so whatever. But NASA goes back to 1880. But around that, since that time, it's been about a degree and some change Celsius of a rise. Now, in the grand scheme of things, everybody says that's rapid. That's not that rapid. Okay, we had much more rapid climate change in the past. Greenland, during the Younger Dryas period, about 11,500 years ago, warmed 10 degrees Celsius in a decade. The global average temperature I've read was about 3 to 4 degrees Celsius in a decade during that rise. So it's not, what we're seeing now is not unprecedented, unless you look at the hockey stick graph. But what I want to point out is that it's not that much. The average temperature at your house where you live probably rises somewhere between 10 to 20 degrees Fahrenheit every day. That's much larger than the change that we've seen since 1880 globally. It's not a catastrophic rise either. People live in Miami, Florida, where it's 70 degrees on an average year round or something like that. People live in Boston, where it's much colder year round. And during the wintertime, it can be below zero in Boston. It can be 85 degrees in Miami. And people are still able to live in both of those climates. So the idea, and that's several, that's what's 85 below zero. That's 80 plus degree difference. So people can survive in these climates that are due to our technologies. So the idea that the warming that we're seeing is catastrophic is not at all. And if you look at the satellite data that's compiled from NASA's Terra and Aqua polar orbiting satellites, and there's two different organizations which process this. One is the University of Alabama, Huntsville, which is by Dr. Roy Spencer and Dr. John Christie. They're on Roy Spencer's the lead, the science team leader on that NASA's Aqua satellite, and then you also have remote sensing systems with Dr. Carl Mears, and they process the same data, but the way they process it's a little bit different. And the both of them do show warming since 1979, and it's not really that much. And the rate of that warming has kind of flatlined a little bit. It's still upward since 1998's super El Nino spike, but it's not that alarming of a trend. But when it comes to the accuracy of the instrumental data, the raw data, I'm not aware of anybody that's actually done plotted the raw data globally, because of the fact that there's just not a lot of thermometer data outside the United States. But in the United States, where most of our long-term thermometer data is, what we find is that the raw data, which Tony Heller plots all the time, even the average data with the maximum and minimum average, there's been very little warming in the United States since 1895, that's when most of our records began. Some locations it goes back to 1893. Some like big cities like DC or Chicago go back to the early 1870s. New York City goes back to 1869. That's the oldest that we have. Then we also have fort data that's compiled by like Army Surgeon General going back to the 1820s for areas like DC and Lawrence, Kansas, and Detroit, Michigan. They go back to like 1821. And I actually was able to access that data from the NCDC. And there's some interesting things if we get to that, I'll talk to you about that you find in that data. But since the National Weather Service started compiling records since around 1895, there's been very little warming in the United States. All the warming, when you see NOAA post those charts, that data is adjusted afterward. And they claim that they adjust it for multiple reasons. One of the reasons they claim that they adjust it for is to account for urbanization. They say, well, we've gotten more urbanized in the United States over the last 40, 50 years, so cities are warmer than they otherwise would be. But if the adjustments were for urbanization, then you would expect that what they would do would be to cool recent temperatures to match the past, or they would warm the past to match the future, to match the present. But instead, all you see is they adjust it and they just find more and more warming each time. And one of the big adjustments that they claim, which you mentioned, was which is called the time of observation bias when they took measurements, because they had this idea that if you took the measurement and you didn't reset it, it would record double, like it was 95 degrees one day and you failed to reset it overnight. In the afternoon, it would record 95 degrees on 2 separate days. But I've analyzed that data, and you never see where they record 95 degrees on 2 separate days. You don't see that very often. And they make this assumption. Now, if this was actually an issue, where they double counted hot days, or depending on when they reset it, they might double count cold days, or low temperatures or whatever. That would be a major problem, but we don't really see that that's a problem. Tony Heller did an analysis on this when he wrote the software to analyze this. He looked at station temperature trends with the time of observation bias and stations without that, and the trends are no different. There's a little bit of a difference in the amount of and where the temperatures are, but that's because locations in the north prefer to reset their thermometers in the afternoon when it's warmer, because it's colder in the north. So they would go outside in the afternoon and reset it. Whereas the south, be really hot in the afternoon, they went out in the morning and reset it. So that's why the temperatures are a little bit different. But the trend is really the same no matter what. So their argument's bogus. NOAA's argument that these temperatures need to be adjusted and all these crazy direct upward, really, because that's all they do is adjust it upward for this reason, is really bogus. And it rests on the assumption that these thermometers that use these min-max thermometers, it's rests on the assumption that they didn't know how to work it. They built the Golden Gate Bridge. They completed that by 1937. The Empire State Building opened up in 1931. They dropped the atomic bomb in the 1940s, but they weren't able to determine somebody wasn't able to figure out how to use a min-max thermometer. That's not really compelling. It just rests on they just assumed that these station owners were stupid and couldn't reset the thermometer. Most people can figure that out within 3 days of having one. So while there might be a few legitimate cases of that, it's by and large, it's not really a problem. So they're just arbitrarily adjusting data for whatever reason. I'm not going to make accusations of fraud, because you can't do that, because extraordinary claims require extraordinary proof. Tony says that they're tampering with the data. and while they might be, I'm not going to go to that accusation because I'm not going to accuse people of fraud without having sufficient evidence. They might have other reasons for it, but it is nonetheless very suspicious that they adjust data. And with the global data, they also do the time of observation bias adjustment. But with each new data set that comes out, version 2, 3, 4, 5, whatever version it is, they always miraculously find more warming. And they claim that, oh, well, we found more temperatures, we found more stations, more weather stations, so we can have more in our network an average amount. If that's the case, though, you would expect the adjustments to kind of go like this. They wouldn't expect them to. Oh, it's very suspicious that each version of NASA GIS's temperature data set or HaCRUT comes out with more data. And what's interesting about this is that HaCRUT. So to back up a little bit, I did a post on this a few months ago, back in, I think it was April, maybe. What happened is that the temperature data set HaCRUT 2 was actually very closely in alignment with the University of Alabama Huntsville's satellite data for the lower atmosphere. HaCRUT 2 is the surface temperatures of the ocean surface, the land surface thermometers, and the ocean being like buoy data or ship data or whatever. HaCRUT 2 was very closely in agreement with UAH, and it showed the least amount of warming since 1979 per se. And RSS, remote sensing systems data, was in very good agreement with UAH, because RSS and UAH, the satellite products, they use the same data from the same satellite, same NASA satellites. The difference in what their products show is how the data is processed and the assumptions that they make in processing the data and calibrating it and whatever and whatnot. But then you had Berkeley Earth and you had NASA GIS showing this rapid warming. The trends were diverging like this, especially after about 1998. And so what happened was HaCRUT 3, or when they updated the new HaCRUT from HaCRUT 2 to HaCRUT 3, and they're now at HaCRUT 5, they brought the data into a compliance with NASA and Berkeley Earth to show HaCRUT now shows more warming. And RSS, Dr. Carl Mears came under pressure in, I think, 2015 or so. I don't remember the date exactly, where he came under pressure from climate activists that his data showed too little warming. And so he wanted to bring it into agreement more with the surface temperature data set. So they put an adjustment parameter or something in there to get the data to show more warming. So even though UAH from University of Alabama Huntsville and RSS, remote sensing systems, they use the same data, they process it differently, and RSS shows a much more steeper warming trend. UAH is now the only data set that doesn't show this as steep of a warming trend. And people always say, well, UAH is the outlier. They're wrong. Well, they weren't the outlier 10 years ago. Two other data sets agreed with them. And the UAH chooses to remain independent. They don't want to be under Dr. Christie and Dr. Spencer want to remain independent of all these other organizations, and they don't succumb to the peer pressure. They just want to have their own independent temperature data set, which I respect them for. And what's interesting about UAH data, what's important to note about it is that it is also most closely in agreement with the balloon data sets that are from the balloon data that's launched by the National Weather Service twice in the afternoon, or whatever meteorological organization does it over in different European countries or Russia or China. So the weather balloon data, you attach the radio sonde to the weather balloon and you launch it, and it records temperature and humidity and pressure and all the other parameters as it ascends up into the atmosphere. The vertical profile for the troposphere, because they look at all the data, the tropospheric temperature changes from the balloon data, which isn't as precise because it's scattered around the world. It's not in a precise grid like you can do with satellite data, where everything's kind of spatially evenly distributed, which makes satellite data superior to even thermometer data. Balloon data is kind of like thermometer data, and it hasn't had the best spatial resolution. But from the balloon data, the temperature trends in the lower troposphere are very closely resemblant to the UAH temperature data. The balloon data does not show as much warming as does RSS satellite data for the low troposphere or the satellite data. So these adjustments that they're making are really questionable. And you can't say that they're being fraudulent, because that requires a lot of proof. And there can even be legal battles with that. You don't want to get a defamation a defamation lawsuit from some of these private companies for accusing them of fraud, because it gets messy, and I don't want to get involved with that. But it is nonetheless very suspicious. And what's also a really important thing to note is that, and I think you're going to find this interesting, is that virtually all climate models, all of them, based on global warming theory and what is understood about global warming theory, in response to greenhouse gas forcing from atmospheric carbon dioxide or methane or whatever, the mixture of them per se, the largest warming, the greatest amount of warming relative to whatever your base state is, should be occurring in the tropical mid to upper troposphere in about the 200 to 300 millibar pressure levels. And even the troposphere overall across the entire globe, especially the mid-latitude and the tropics, should be warming more in response to greenhouse gas forcing than the land surface, if it's caused by greenhouse gas emissions. Now, the surface on the other, but the thing is, I'm getting ahead of myself. McKittrick and Christie, 2018, a study published in, I believe, Geophysical Research Letters, if I recall correctly. They talk about this, and they plot the models. They look at the models. You could find all the other models. I think they plug in the Canadian model in the study, but if you look at their supplementary information, you can find that you can find all the other models. You can find the UK model, the US model, and the German model as well. And they all show this big hotspot. And this is over the period simulated from 1958 to 2017. There should be all of this warming in the troposphere, but the actual observations show that the models are warming twice as fast as observations. So the modeling is warming way too much, and the observations are not showing that warming in the troposphere. If you look at the global cross section or the time series, it's not warming as much. And what this implies is, for one, is that the atmosphere is not as sensitive to carbon dioxide emissions as organizations like the IPCC claim. And that means the equilibrium climate sensitivity, the effect of warming from doubling carbon dioxide concentrations, is much lower than the IPCC estimates, potentially up to over a degree lower than their estimates. The other implication of this is if you actually look at the observations, the land surface is warming faster than the atmosphere. Now, one could argue that, okay, well, the land has a much lower specific heat than the air. So obviously, the air is going to warm slower than the land. And that's true. But if it is greenhouse gas forcing, according to global warming theory, to all climate models, it should be the atmosphere that's warming faster, not the land. So if the land is warming faster, then that has to be due to something else. And if we look at where it's warming the most, we see it in the northern hemisphere. Now, obviously, okay, one could then argue, well, the southern hemisphere is mostly ocean. And the ocean also has a very high specific heat, similar to air, although the water has very much higher specific heat than air. So ocean temperatures are going to be much slower to change. So obviously, you're going to see more warming in the northern hemisphere. But if you look at the land data only, you see most of the warming is in the northern hemisphere versus the southern hemisphere. And what that tells you, and Dr. Ross McKittrick is working on a study on this, and I think he's already published a couple on this in the past. This fits more of the spatial patterns of urbanization, where most of our thermometer data comes from. So a lot of the warming that we are seeing, and Dr. Spencer, Roy Spencer, UAH, he's actually working on, I think, a study on this as well, hopefully published maybe later this year. He's been talking about it. I don't know when his deadline is that he has for this. But what they're finding is that most of the warming that we are seeing globally might actually be due to the urban heat island effect, not necessarily carbon dioxide. It doesn't mean carbon dioxide doesn't have an effect, because in and of itself, global warming theory does make sense from a physical. If all else is held constant, then adding carbon dioxide, it is a greenhouse gas, so adding more of it to the atmosphere should cause warming. But the atmosphere might not care that much.
Let me cut you off. Let me cut you off. Let me cut you off right there to ask a question. And I've always taken the position in life that me as a relatively smart individual should be able to see a phenomenon, look at data, and recognize it. Like I may need to go to the doctor that tells me I have a virus, a flu, give me medicine, but I can tell when I have a fever or I have a runny
Yeah.
nose, right? And so, just as a layman sitting there looking at the data, the theory is we've emitted CO2, we've taken parts per million, 300 to 425. Therefore, that has caused the warming. When I look at the data over the last 150 years, 175 years, it actually looks like temperature is going up and then CO2 levels are following it, i.e., the reverse of the theory. And so I kind of just in my mind did a an experiment, thought experiment. I like Diet Coke, right? It's carbonated. It's great. When I sit it here and drink it when it's cold, boy, it's fizzy. When it warms up, all the CO2 is gone and
Yeah.
it's flat. Is there any chance that there's actually what we're seeing is just correlation and not causation? Or can we test it in the lab that CO2 going up will lead to temperature going up? It's actual causation.
Yeah, that's an interesting question. Actually, it's one of my other favorite questions I've received. Now, yeah, and you're right. In the historical record, if you look like going back during the ice ages, the if you look at the graphs, it does appear CO2 does actually lags temperature, so temperature changes first, and that's true initially. That is true initially, but what happens is somewhere when during that, so the temperature starts to rise, and that's due to orbital changes and axial tilt changes on the Earth's the wobble on its axis and its changes in orbital shape around the sun, and those occur on tons to hundreds of thousands of year timescales. So the temperature starts rising, and then CO2 starts rising after, and then eventually there's a point where CO2 starts to rise, then and then and then temperature follows the CO2. Um, but this idea that CO2 is the control knob of the climate, this really isn't. Historically, that's never really been the case. Um, so it has an effect, yes, based on what has been theoretically calculated in the radiative transfer equations and the laws of physics. It makes sense. The problem is, as you point out, is that it cannot really be tested in the lab. There's been attempts at lab experiments, and some people say that there's proof, but there's a number of flaws with how they do this because the thing is you cannot replicate an Earth atmosphere in the Earth system in a lab. You just can't. And there's a lot of issues with that. Like Bill Nye, for example, did the carbon dioxide in a jar experiment, and he basically fabricated that entire experiment. He got called out on it by my friend Anthony Watts. He was a former TV meteorologist, and he runs the What's Up with That blog. Um, so you can't really prove any of this in a laboratory experiment, much less a computer model simulation, which is basically is you can make the computer model say whatever you want. It's much less of a scientifically accurate um, test to run than something you can do in a lab, which is based on a much number of because it can be in a computer. You can get a computer to tell you whatever you want it to in a program. But you're all right that in the sense that the solubility of carbon dioxide in water decreases as temperature rises. So what we see is that when the water warms, such as the ocean, its ability to dissolve carbon dioxide into it decreases. So you get CO2 actually emitted out of the ocean, and that in and of itself can have some effects as well on the climate. Probably not again because based on the observations, what I was talking about with the satellite data and the tropospheric observations and the global cross sections, and based on the climate models, the climate's not as sensitive to CO2 as the climate models suggest it is because we haven't seen these observations. So while it might have an effect, and in all theory it makes sense, um, the observations kind of tell a different story. And most of the warming we're seeing is probably due to urbanization. Um, so carbon dioxide does lag temperature. It can lag temperature. It doesn't always lag temperature though. It just depends on the time scale. Because again, in the geological record, temperature precedes CO2. So CO2 follows temperature, then eventually there's a changeover. But then temperature starts to fall, CO2 starts to fall. So it kind of goes back and forth a little bit. But I wouldn't say that doesn't Just because CO2 does eventually take over, it doesn't mean that CO2 is the control knob of the climate. There's a lot of things we don't know, and these scientists out there pretending that we have the answers to everything on a planet that's 4.5 billion years old, and we only have data that's really solid over the last 100 years, and not even that necessarily. Maybe even only the last 50 to 70 years do we have a really good picture of anything on a planet again that's billions of years old.
Interesting. So, I get on my soapbox about the energy business and that we don't tell our stories. We're not very effective at marketing. And I think that's because we create a product that we just sell into the market. I mean, we're not Nike versus Adidas, right? And have to market my barrel oil is better than yours. We just sell it into the market. So there's no marketing culture, no storytelling culture. Number two, we're just a bunch of fucking engineers, right? I mean, and engineers can't tell a story to save their lives. I mean, God bless them. No offense intended, but we're not good at that, and so we kind of just have a tendency to shy away from telling our stories. And in a vacuum, what happens? The other side and their stories dominate the narrative, become accepted, etc. And then when we finally do tell a story, we go with facts, figures, and reason. And if you look at the psychological studies, literally the worst way to change someone's mind is facts, figures, and reason. It's actually the way you change somebody's mind is the Socratic method. You ask questions. That's that's why Socratic method is such a great teaching methodology. Two, you scare them. I mean, you can change someone's mind by
Yeah,
scaring them, and I think the other side has done that. Three, the other thing you can do is you can make people laugh, and it's not make you laugh. It's not make your echo chamber laugh. It's the undecided person or the person you're trying to persuade. Make them laugh, and I think if you kind of summarize all those up, it's storytelling, connecting on an emotional level, etc. So with that as kind of my diatribe standing on my or from my bully pulpit here saying it out, what do we do to get a more fair and accurate and thoughtful discussion about all this stuff? Because I've always said we ignore this at our own peril. I mean, we really could be messing up the world, and we need to be careful and thoughtful, and we could potentially be doing bad stuff. But at the same time, I was sitting in a meeting for my church, and we were talking about what to do our endowment. Somebody brought up, well, climate change, we need to invest for that. And I go, all right, let's take your net worth and bet it on whether it's going to rain in 18 months or not. You willing to do that? And so anyway, that how do we change hearts and minds so that we can be thoughtful about this and constructive? Or is this just going to be the rest of society where we just punch each other in the face?
it's a good question, and I've wondered that myself. Because I always try to. I've come to realize that just putting facts out there doesn't really change people's mind. People that are really beholden to this ideology, and it really is. A lot of these people, climate activists, and even it's a lot of the scientists who echo their messaging. Although I find that most scientists are prudent to go on the doomer rhetoric. They might not necessarily agree with my position on everything, but they don't subscribe to the end of times rhetoric, or that we have these deadlines. That they just believe, okay, we just the sooner we stop this, the less consequences we have. Which is, even though I don't necessarily agree that there's going to be these severe consequences, I can respect their position for that because they back their evidence with data. I can agree with it or disagree with it, but they're not doing this cultish preaching like Greta Thunberg. But what I found that a lot of these people, scientists like Michael Mann or Peter Kalmus from NASA, a lot of these people really are atheists and they have abandoned God and normal religion, but they have not abandoned religion entirely. If they instead substitute it with science as this deity that cannot be questioned. And if you question it, you're a heretic, you're a denier. Um, and I think that really these labels, and I'll even admit that labels in general, even maybe climate doom or climate disciple or climate hypochondriac, which I use all the time just to just go around at people, and because they think that denier accurately describes me, whereas I think maybe they're hypochondriacs. But I think that in general, we should all really stop using that kind of language, because slapping labels on people, and I'm guilty of it myself. I admit it. I'll be the first to admit to you that it doesn't really uh, necessarily help the discussion, and it's not really fair necessarily. Because as much as I don't like being called a denier, because I'm not, that person might not really be a hypochondriac. Well, climate activist, that's different, because a lot of people are climate activists. They describe themselves as that. So that's more fair label. Um, but what I have found that a lot of these people, though, they're so religiously invested into this that you can't change their mind with facts. They can say summers are getting hotter in the United States. And then I show them a graph of the number of days above 90, 95, and 100 degrees, or 95, 100, 105 degrees. Or I look at the average summer maximum temperature and I show them that it's been declining for the last 90 years. They're still going to come back and say it's getting hotter. Or they'll say tornadoes are increasing. And then you show them a chart of EF1 to EF5 tornadoes, and there's no trend since 1954. And they'll say, but they are going up. You excluded EF zeros. And you can tell them that the EF zeros have increased, like the really weak tornadoes, because there's been an increase in the rural population since 1954. And we also had the introduction of the WSR-80, Doppler radar system came online for operational use in the early 1990s. And since then, there's not really been a trend in EF in total tornadoes, but since 1954, there has been in total tornadoes. So you exclude the weaker tornadoes, you look at the more intense ones, and there's not much of a trend at all. But you can explain that to them. NOAA even talks about this on several other sites, on their NCEI page as well as their SPC page. You can find literature on this in the AMS journals or Nature, Science Magazine, whatever. You can find studies on this. They talk about it, but you can point out to them that, and they're still going to come back at you and say, "Well, tornadoes are getting worse." There's no reasoning with these people. And on the other side, and they might think the same with us. You got to look at it from their perspective as well. They might say, "Well, he's not understanding my point." So I think that when you ask people questions, and what's really interesting to me is that, and you make a good point, because when you ask people questions, it scares them or intimidates them, and it makes them think. It gets the wheels turning in their mind. And I have noticed that when I post charts and data, they just get into this back and forth argument with me. It's unhelpful. I end up blocking the person because I get pissed off and irritated, and I don't want to deal with it anymore. And I don't like blocking. I don't do it often, but sometimes people just need them to go away. But what I do find is that when I ask them really tough questions, they don't ever come back at me. As an example from today, is this person, I'm looking at my Twitter right now, this person replied to me in all caps. I told him his caps lock was on. I don't know if he noticed or not. But he said the last 12 months were the hottest months ever recorded, and likely the hottest in the last 100,000 years. Okay. Well, that's an extraordinary claim. All right. And that requires a lot of proof. And so instead of arguing with him about proxy data from tree rings or ice cores or whatever data set you want, I asked him, if you're confident in that, then tell me what the global average temperature was for the year 34,562 BC to the nearest 10th of a degree Celsius, and that individual did not reply to me. So when you ask them really tough questions like that, I think that is the way that we need to approach this, is because I think that's going to start getting the dialogue moved in a more productive direction, a more positive way forward, is if we start asking tough questions like that make people think. Because if you just feed them data, that's not going to really convince them. But you have to ask questions, and you have to be kind of provocative with it. Because if you're provocative, I make provocative posts all the time because I want people. I don't do it because I'm being snarky or because I'm got an ego, because I really don't. I'm no better than anybody else. I'm just me. But I like to make provocative posts to make people laugh, for one, because I'm funny. I get that from my dad, and my family. I got a good sense of humor, but I also do it to make people think. I want people to think. I don't want people to just regurgitate what they're told. I don't want anybody to believe what I'm telling them. I want you to go double check the data for yourself. I want you to think about this for yourself. I think that's how we do it, is ask questions, because as you pointed out, it makes them intimidated, it makes them scared sometimes, and they run away. They don't want to confront you with it because you put them in a tough position. But in the end, I think it makes them think and it makes them reassess their position a little bit.
So I've got a suggestion for you because I think you're the guy to do this. You've got a great demeanor. I was totally kind of expecting flamethrower podcasts, and I think you and I have been fair and thoughtful and asking questions and kind of base load type questions you should be asking before you come up with any policy prescription. Have you ever read the book Factfulness? Do you know what I'm talking about?
No, I've not. I haven't even heard of it actually.
Okay, so email me your address. I'll send you a copy of it. The short version of what Factfulness is it's a Swedish doctor who went to Africa and various places, economically disadvantaged places, because he wanted to save the world. And one of the things he noticed was that the world was actually doing a lot better than people thought. And so he went to UN data. So he didn't even create his own data set. He went to UN data and he created a simple little quiz of 13 questions. And he would go to audiences and speak. And the questions always had three different choices, A, B, or C. And they were questions like, what is the average difference between the years of education that a boy gets on the planet versus a girl? Is that 1 year difference, 3 year difference, 5 year difference? And so he would ask these simple questions. And, the perception, most people would answer C, 5 years
Yeah.
difference. Men get so much more education than women. Actually, the UN data says it's
Yep.
1 year difference. Average guy on the planet gets 10 years of education, average female gets 9. And he would give this quiz and they'd tally up results, and on average about 10% to 15% of the audience um, would score higher than 3 or 4 right. So I mean, if you're just a monkey throwing darts, you should get 3 or 4 right,
Yeah.
right? Because there are only three choices, A, B, or C. um, and he would give this speech to dignitaries. He gave it to the UN, all the fancy investment banks, law firms, etc. And on average, people would get, one or two right, and they'd miss the rest. And he'd say, "You don't have the fundamental education to discuss any sort of policy worldwide because you don't even have the facts right." And I think you could do something like that too, where it's 10 to 15 questions, just simple type questions, and not even flame throwing questions, just stuff I see you tweet every day. You could go talk to kids about that. And, if the kids are scoring one or two questions right, you're like, hey guys, you're not being taught the underlying facts. And maybe just kind of from that level of just, hey, you have to acknowledge you don't get this right. And I'm using NASA data, or I'm use some accepted data, but find some questions that kind of go against the current narrative of something. I think you could do a cool little shtick like that that just drops a little bit of cynicism into folks, and maybe gets them to ask why, because you've got as good a grasp on all this as anybody that I've seen. My dad used to tell me what to wear to school every day based on what Bastardi would say on the radio, and so kind of followed this from a long time. But anyway, just my 2 cents worth as a reformed private equity guy that's tried to become a social media influencer, because I really am a big
Thank you.
fan.
Yeah, I think that's actually an amazing idea. And what's cool is that, so because I'm interning with CFACT and the Committee for Constructed Tomorrow, we got a wonderful team. I love everybody; they're all fantastic. It's a great workplace environment. Um, but we get to do so. Some of the people that do that work for them, they go around and they give talks at schools, universities, wherever. And that's something that because I got a full-time job offer after college, after graduation. And so if I choose that and I decide that's what I want to do, and I get to go around, I'll probably get to go around 2 universities around the country and give talks and stuff. And that's actually a really wonderful idea. I think that would be highly effective in really getting people to change minds, at least the younger generation, because that's kind of what I try to aim at, is because that's the climate activist movement, the people that want this kind of authoritarian agenda. They rely on young people believing what they're saying. If you can alarm them about the climate, you get them to comply with, okay, well, this is bad, and we're going to vote for this politician who promises to solve this. Um, and they get this idea in their head that the government can actually fix problems. The government just only creates problems. Anybody who's opened up a history textbook knows that. And it doesn't matter if it's Republican or Democrat administration.
Anybody that drives on a road and there are
Yeah,
potholes
yeah. Where's our
everywhere.
tax
I mean,
dollars going?
couldn't we start with fixing the
Yeah, have you
potholes
driven
on the
through
road?
Pennsylvania?
Yeah.
That's where I go to school. It's a university. It's awful up there. It's bad. Thankfully, here in Virginia, the potholes aren't really much of a problem. They tend to keep the roads really nice over in Loudoun County. Um, but it's important because I think that if I get this opportunity to go out and speak to people, I actually would really like to start out maybe like doing a question like that. Maybe doing like a Google Forums question, and you can get people in real time. They can answer the 10 question quiz, the ABC, maybe B, and see how many of them get it right, and then go through like a presentation on what I want to talk about. And I think that if I do that, I've seen people do stuff similar to this, not necessarily the question format, which I really like. That's a really great idea, and I'm gonna take that and pitch it over to Craig and Mark and the people I work with, give them that idea. Um, but I think that'd be a really good. I've seen people like give talks and stuff where like there was like the Steve Koonin debate with was it Michael Mann or Andrew Dessler, I think is who it was, not Michael Mann.
It was Dessler. Yeah.
Dessler, yeah. And people went into they just had a debate, and people went into it. They took most of them took the side of Dessler, and by the end of that debate, most people took the side of Steve Koonin, and that was just simply just debating the facts. And I was surprised that that was able to persuade people. But if you can do that with a presentation like that, where you're laying out the facts, I think you could even enhance that based on doing like a question. Like, and then if you point out to them you kind of do that kind of that tongue-in-cheek stab at them, is if you can't get these questions right, then you have no business discussing the policy. You have no business discussing what kind of energy policy we should be having and dictating that for 333 million Americans. You don't have a voice in that if you can't get the facts right. So I really think I'm really going to take your idea with that, and I'm gonna. That's a really great idea, really wonderful thing. I think we could.
I'm gonna send me your address. I'll send you a copy of Factfulness. It's a big thick book, but it's a quick read. And his whole point is just the world's so much better than we realize. It's not in as having all the dire
Yeah,
consequences. And we really ought to look at this as a positive, and let's refine our policies not to assume the world's in this horrible place, but let's get better bang for our buck. And so I think there are a lot of applications, and it's a well written book and it's engaging. And I think kind of using that as a template for you, it's worth the 4 or 5 hours it takes you to read the book, because it's really pretty good. Well, you've been cool to come on.
yeah. This has been fun. This has probably been one of my. This has probably been like probably my favorite podcast that I've done so far. So I would definitely be interested in coming back if you're willing to have me back.
Standing invite to come on the podcast anytime you want. Standing invite anytime you want to come to Houston and meet a bunch of folks. We're always happy to host you down here at Digital Wildcatters. And we do probably 7 or 8 events a year. We do these energy tech nights, what I call Shark Tank meets WWE. We get four or five energy tech companies pitch their products. Everybody's drinking beer and eating pizza and lights and cameras, and we vote, and the winner by audience applause. So something really scientific gets a wrestling belt, and we do product demos and stuff. Those things are great. So anytime you want to come to one of those, we'd love to have you. We'd love to have you, maybe do a fireside chat for 15 minutes, kick off one of those. And then we also do Bitcoin mining for the energy business. We just think Bitcoin mining is a pretty neat tool for oil and
Yeah, I've
gas
heard about
companies,
that.
even beyond just having stranded natural gas.
Pretty cool.
So we'd love to have you down for that, and anything wherever you go to work, whatever organization you wind up working for. Love to brainstorm any day to see how we can help each other.
Yeah, CFAC works with a lot of people like CO2 Coalition and Heartland Institute and other organizations. So I'm sure that Craig and all of them would be willing to do that. And it's a really great group of people. I'd be interested in coming down. I've never been to Texas before. I've been to 32 states, but Texas is not one of them. But I have an invite from Chuck DeVore.
Dude,
I
you're
know,
missing
that's what I've
out.
heard. My dad says Texas sucks. I'm like, there's good parts of Texas. People are moving there for a reason. But and I got a buddy who lives. His brother lives in Dallas. He works for Geico, and he has a nice big apartment. He does really well for himself. And he lives in Dallas. He absolutely loves it down there. And I've heard great things about Houston and Dallas in particular, Austin, I believe. So I want to go down. I have an invite to go down to the Texas Public Policy Institute. Chuck DeVore wants me to come down there. And it's a long drive. I don't want to fly if I don't have to. So I'm thinking about maybe driving down during my fall break, which is in October. Maybe get one of my buddies from my school to come down, and maybe I can shoot down to Houston as well. So I'll let you know, but I would love to come down. So
Hell, I'm unemployed. I'll fly up there and drive down with you. It'll be fun. We'll just set the camera rolling, do a buddy movie all the way down. Well, Chris, I really appreciate you coming on.
Thanks for having me, Chuck. I really appreciate it. It was a great time. It was really informative. Good discussion. I learned some things and got some new ideas. So I can't wait to pitch those over to my team and see what we can do.